In this video, we'll go over one of RISA-3D version 20's newest features, the seismic design of masonry shear walls. We'll go how we can easily define a seismic design rule and apply it into masonry wall panels, and go over the seismic detailing checks performed by the program in conformance with the requirements and provisions of TMS 42-16. To get started, let's take a look at our model. The model was originally modeled in RISA floor for a preliminary design of gravity forces, and it consists of an interior steel skeleton connecting to a set of perimeter masonry wall panels forming the lateral system. The interior steel skeleton connects into the wall panels and supports some of the gravity forces that were originally model and RISA floor. And now with the integration into RISA-3D, some of these gravity forces transfer over and is being supported by each of the perimeter wall panels. And as you can see, there is a basic load case for dead load, where some of the dead load gravity forces transfer over and it's being supported by the masonry wall panels. In a similar manner, we can take a look at basic load case 2 for live load, where we can see that the live load is being supported in a similar manner to the dead load. Now, in this case, in RISA-3D, we are going over the lateral analysis and design of the set of perimeter wall panels. And if you are starting in a RISA-3D only model that has not been integrated with RISA Floor, the process will remain the same. We'll go over the process for the seismic design of masonry wall panels, and it will be the same for either models originating from RISA Floor or models starting from RISA-3D. Having said that, we can start taking a closer look at what the lateral forces will look like. During the integration, lateral forces, seismic forces were generated via the use of the seismic load generator, which we can see by displaying these seismic loads. And to do this, I'm going to turn off our rendering view and switch to a wireframe view and turn on our diaphragms. And as you can see, the purple outline in there represents each of the diaphragms at each of the levels. And I'm going to switch the display loads from basic load case 2 to a basic load case of 14 for earthquake load X. And as you can see, you will see nodal forces applied at the center of mass of each diaphragm for earthquake forces along the X direction. And in a similar manner, we can do the same for the Z direction by changing the display basic load case from 14 to basic load case 17. In this case, we have a set of nodal forces applied in the perpendicular direction to the x-axis along the z-axis. And each of these nodal forces is applied at each of the diaphragm levels, representing the equivalent lateral force method used in the seismic load generator. And if you are starting in a RISA-3D only model and you have not applied any earthquake forces into your model, you can easily do so by going into the advanced tab and going to the seismic load generator. And in the seismic load generator, you have the option to set a design code. In this case, we're going with ACE 716, apply the risk category, apply your site parameters for your structure as well as your structure characteristics. And you can hit here calc loads, and RISA-3D will calculate your seismic forces for you. It will determine what the effective seismic weight per floor is, it will determine the seismic force along the X and the Z directions, as well as the center of gravity of each diaphragm. And you will place those loads into the center of mass, center of gravity of each of those diaphragms. And once you have done that, you can hit generate. In this case, since I already generated these forces, I'm just going to hit close. And it's important to point out that whether you start in RISA floor or you use a seismic load generator or not, in order for the seismic provisions to be applied for masonry wall panels, forces must be applied and solved in your model with an earthquake load category. And to see this, how that's been done already, we can go into the Home tab and open the Basic Load Cases spreadsheet. And in the Basic Load Cases spreadsheet, if we scroll down, we will see that there's already some earthquake forces with an earthquake load category. So these would be your EL, ELX, ELZ load categories. So these represent earthquake loads in your model. So since these have already been applied, I'm going to hit X in here and go ahead and open the model settings. And in this case, I'm going to the codes tab, and within the codes tab, I'm going to make a choice for the masonry design code. We're designing for masonry wall panels. So in this case, I'm going to choose TMS 42-16, the strength design philosophy. It's important to point out that this feature is available for TMS 42-16 and ACI 530-13, either the ASD or strength design philosophy. So as long as you make a choice for each of these, for any of these four codes, the seismic design provisions will be applied for masonry wall panels. Having said that, I'm going to hit OK in here. And now we're going to start looking at the wall design rules for our masonry wall panels. I'm going to go ahead and open the wall design rules spreadsheet and go into the masonry wall tab, where we can see that there's two masonry wall design rules defined, one with the label of typical, which has already been applied into the model by default, and there's an additional one called solid walls. And this is the wall design rule that I'm going to apply it into our masonry walls that are solid, those that do not have any opening model in them. And as you can see, both of the wall design rules have a nominal block width of 12 inches. They're both fully grouted and they are reinforced. And let's take a look at our reinforcement by going into the masonry in tab. When I click in there, the typical wall design rule has a number 5 vertical bar size and a number 4 horizontal bar size, and the solid walls wall design rule has a number 4 vertical bar size and a number 3 horizontal bar size. As you can see, the reinforcement is slightly different between the two wall design rules. And now that we have defined that, let's go ahead and apply this wall design rules into our masonry wall panels. And to do this, I'm going to select the solid walls in the model, and we can do this via the use of a selection state that has already been defined. And to do this, I can click in here and open the selection states dialog. And as you can see, there's already a solid walls selection state already defined, which I can retrieve by clicking in here, the retrieve button, and it will select automatically this selection state. In this case, we have all of these solid wall panels selected in there. And now that I've done that, I'm going to go ahead and apply the wall design rule for these wall panels are selected into a solid walls design rule. So now I have applied a wall design rule of solid walls for these wall panels. And now for the remaining wall panels, I'm just going to verify that the typical wall design rule has already been applied. To do this, I can do an invert selection by going into this invert selection tool in here. And essentially, it will invert the current selection state of the model, essentially anything that was not selected previously. And I'm going to be making a more specific selection in here. In this case, I'm going to choose only the masonry wall panels. And as I have done that, I can easily apply a design rule of typical. It looks already it's been applied into our masonry wall panels with an opening. So now that I've done that, we can start taking a closer look at how to apply a seismic design rule into our masonry wall panels. Essentially, there are two ways to do this. One is either via this new property that appears now for masonry wall panels called seismic rule or seismic design rule, which has predetermined seismic design rules already defined. So these will be ordinary, intermediate, and special. And we could take a closer look at what these default seismic design rules are all about by going into the seismic design rules spreadsheet, which is the other way to apply a seismic design rule into our model. So in this case, once you open the seismic design rules spreadsheet, you can go into the masonry walls tab. And as you can see here, there's 4 inputs into a seismic design rule for a masonry wall panel. So this will be a seismic design rule label. In this case, will be ordinary, intermediate, and special. These will be the default seismic design rules. The wall type, in this case, there are 3 wall types available in RISA-3D. So these will be ordinary, intermediate, and special. Ordinary will have the program perform seismic detailing checks per chapter 7 of TMS 42-16. Intermediate would have the same seismic detailing checks apply as an ordinary wall type with an additional requirement for vertical reinforcement. And special, which is the stringent out of all the wall types, which have seismic detailing checks performed per chapter 7, 8, and 9 of TMS 42-16, depending on which design philosophy is chosen. So if you choose a masonry design code of ASD or strength, it will have different requirements depending on each design philosophy. So having said that, we can go ahead and look into our next input, which is the special boundary elements checkbox. And this checkbox basically tells the program, if you have it on, that you want to meet the utility requirements via the use of special boundary elements, that you would like to have special boundary elements in your wall panel. And what that tells the program is to perform and look for the specific checks that will determine whether special boundary element is required on your wall panel. And if you have this setting turned off, then the program will proceed to perform the seismic detailing checks with conventional reinforcement. This tells the program that you want to meet your utility requirements using conventional reinforcement. So this will be your vertical and horizontal bars have already been defined in the wall design rules spreadsheet. The next input is the 1.5x shear ASD input, and it essentially increases the shear demand in your wall panel by 50%. And this is actually a requirement for special wall types. So any design rule with a special wall type will have this seismic detailing check performed to ensure that you have increased your shear demand by 50%. And in this case, I'm going to keep this turned on in here for the 1.5x shear ASD seismic design rule for special, and the special boundary elements, I'm going to keep it off. I'm going to proceed with conventional reinforcement to meet the utility requirements. Having said that, I'm going to hit X in here. And now I'm going to do a square selection of our model to apply the seismic design rule. I'm going to do a whole selection. I'm going to keep this selection as Masonry wall panels. There are 30 wall panels in there. Great. So now that I've done that, I can go ahead into the seismic rule input and choose special. So it looks like all of the Masonry wall panels already have a seismic design rule special, and this is because I have integrated this model from RISA-4 into RISA-3D. By default, that's the seismic design rule that gets applied, but you can easily change this by doing a selection again of all your wall panels and changing it in here, depending on which seismic design rule you want to apply and is required for your project. So now that I've done that, I'm going to hit escape to undo my selection. And now I'm going to open the load combination spreadsheets to generate our load combinations. And to do this, I'm going to hit the LC generator, load combination generator. And as it opens, we can see that in the gravity tab, we can generate gravity load combinations by choosing a region. In this case, I'm going to choose United States with a code of IBC 2018 strength design philosophy. I will generate those load combinations using this code. I'm going to generate my deflection load combinations, and I'm going to keep all of these settings off for this case and hit generate. And as you can see, the load combination spreadsheet starts to get populated by these generated load combinations. And in a similar manner, I'm going to go ahead into the seismic design tab and generate those seismic load combinations as well. I'm going to keep these settings in a similar way, region and code per United States in IBC 2018. And in the seismic load options, I'm going to choose an X and Z direction. So that will generate load combinations for seismic load along those global axes. I'm going to make those loads reversible, and I'm going to include the redundancy factor. Now that I've done that, I can go ahead and finish putting up the inputs for seismic load combinations. I'm going to keep overstrength load combinations options as none, and the capacity limited LC options for brace frames is not really applicable for us. I'm going to hit none in here and hit generate. And as you can see, we have generated about 13 load combinations based for gravity forces with deflection load combinations and our seismic load combinations. So now that we have done that, we can go ahead and solve our model by going and hitting the solve batch plus envelope button in here within the load combination spreadsheet. And as the model solves, it's important to point out that currently in the model, we have the same seismic design rule apply into all of the wall panels. But in the case that you have different seismic design rules with a different wall type included in each of those seismic design rules, the seismic detailing checks that will be performed by the program will be different. Each of these wall types have different requirements per TMS 42-16. So just keep it in mind in the case that you don't see the same seismic detailing checks being applied into each of those wall panels. All right, we got results in here, so I'm going to hit close into the no reaction spreadsheet and close out of the load combination spreadsheet. And now we can get started at looking at our results. And to do this, let's take a quick look at our deflector shape and turn on our deflector shape by going in here in this button and it would turn on our deflector shape for a specific load combination. So in this case, we have load combination 1 display, but in the case that we want to look at another load combination, let's say one of the seismic load combinations, we can easily change this and go to one of the latest load combinations, let's say load combination 10. In this case, we make a choice for our seismic load combinations. And as you can see, the deflector shape will actually update for this new load combination that's been chosen. As you can see, there's not any major deflection in the structure, which is great. So now let's start taking a closer look at our design results for each of the wall panels. And to do this, let's go ahead and turn off our deflector shape. And I'm going to turn off the diaphragm just to have a better view of our model. And now that I've done that, I'm going to go ahead and go into the wall panel design spreadsheet, which is located over here at the bottom, and open this spreadsheet up. And as you can see, it opens up in the Masonry end tab, which basically tells us all the design results for the end plane analysis and design of our wall panel regions. In this case, we have the wall panel label and there with each of the regions located, and the results are provided for each region. In this case, we have unity checks for axial, bending, and shear. It looks like all of these unity checks are pretty low. They're all less than 1, which is great. It means that the end plane analysis and design checks out. The shear, axial, and bending demand is less than the design capacity respectively for end plane. And in a similar manner, we can go ahead and go into the Masonry out tab to look at our out of plane analysis results. And as you can see, the axial bending unity checks are pretty low, so it's expected. We don't have any major out of plane loading applied into our mainstream wall panels. And now with the seismic design implementation of RISA-3D, there's a new output, a new tab called Masonry Seismic. And in this case, we're going to find all of the design results for our seismic design in our Masonry wall panels. We will have information for the wall panel labels, for all the wall panels, the seismic design rule that has already been applied into each of the wall panels. In this case, we chose special. We're going to see output for each of the wall panel regions, an in-plane unity check for shear for each of the wall panel regions. As you can see, they're pretty low. They're all less than 1, which is great, along with its governing load combination. And now there's a column that is called seismic detailing, and it essentially tells us a summary of all the seismic detailing checks in the wall panel region. So if it says pass, that means that all of the seismic detailing checks performed in a wall panel region pass. And if it says failed, let's see if we see a fail one. Here we can see fail. It prompts the user to see the detail report. And it usually means that there's at least one seismic detailing check that fails. And this is when this is the case, the summary would show a fail. The last column in here shows the BZ required, essentially tells information whether a special boundary element is required or not. But in this case, because we have defined a seismic design rule without special boundary elements, the output will always be no for this case. So let's take a closer look at what these seismic detailing checks are all about. And to do this, let's take a look at a failing one. I'm going to click in there and do a right click to open the detail report for wall panel 14A. And as you can see, this wall panel is a solid wall panel with horizontal and vertical reinforcement, somewhat of a close spacing in each of those reinforcement. It has a seismic design rule of special and a wall design rule of solid walls. Now we can start taking a closer look at the results. If you scroll down, it looks like all of the traditional design checks out. So that will be for in plane and out of plane for region R1. We have a pass result, which is great. And now with the seismic design implementation in RISA-3D, there's a new output called seismic detailing, and it's independent for each wall panel region. So each wall panel region will have its own seismic detailing section at the bottom of the detail report. And we can take a closer look at what these seismic detailing checks that have been applied in this wall panel region by expanding on this wall panel region R1 for the seismic detailing checks. And as you can see, there's prescriptive seismic detailing checks applied into the wall panel region around openings, at the wall edge, at the top of the wall. There's additional seismic detailing checks for horizontal reinforcement, such as minimum horizontal bar size, maximum bar spacing, minimum area of steel. Similar manner, it is done for vertical reinforcement. Going a little bit down, we can see the maximum flexural road check, which is essentially a check to determine the strain levels at the steel layer reinforcement at the extreme fiber, tensile strain fiber, and essentially determines the steel strain ratio by taking the strain level at the boundaries on reinforcement divided by the yield strain and compares this steel strain ratio to a value of alpha. And this value of alpha is essentially a minimum strain ratio, and it depends on both the shear span of the wall panel and the R factor, the seismic response modification factor that is input within model settings for seismic. So if this checks out, if the steel strain ratio exceeds alpha, then that means that this maximum flexure road check passes and essentially tells that the masonry wall panel has sufficient ductility, which is great. We're meeting one of the seismic detailing requirements per TMS 42. Scrolling down a little bit more, we can see the seismic shear capacity check essentially determines what is the minimum required shear capacity in the wall panel and compares that into the actual design capacity. And if that checks out, we also get a pass result for this seismic detailing check. And lastly, we have a motor check. And this motor check essentially checks whether we have provided a type M or S mortar cement for our wall panels. Having said that, it's important to point out that all of the requirements for each of these seismic detailing checks is provided in this right column. So if you want to get an idea of what each of these calculations being done, for instance, the reinforcement around openings, it requires a number 4 bar within 16 inches of each side of the opening, and a number 4 bar at top and bottom of the openings. When the program performs this check, it's looking for this specific requirement, and if the wall panel region is not around an opening, then essentially this seismic detailing check is not required, and a non-applicable result will be provided for this seismic detailing check. In a similar manner for, let's say for instance, at the top of the wall, it requires a minimum horizontal bar size of number 4, and it shows that a fail has been provided. Let's take a closer look at that. So if we scroll all the way up to into the rebar diagram for this wall panel 14A, we see that number 3 bars at 5 inches of center has been provided. Since it's a number 3 bar for horizontal reinforcement, that means that we're not meeting that seismic detailing check requirement of number 4 bars. So let's go ahead and try to change this. I'm going to hit close in here in the wall panel detail report. I'm going to go back, hit close here again. I'm going to go back into the wall design rules spreadsheet and change the horizontal reinforcement for the solid walls design rule, which we saw was applied into that wall panel, change this horizontal bar size into a number 4 bars. Essentially, that will clear my results, which is good. We will have to resolve our model. I'm going to hit X in here, and I'm going to hit solve for a batch solution for more combinations with the inclusion of our envelope solution. Now that it's done, I'm going to hit solve in there. And now that I'm solving my model with a new wall design rule, with an updated wall design rule to include a number 4 horizontal reinforcement, we'll see that some of the seismic detailing checks will start to pass as it is we're providing or meeting one of those requirements, which is having the number 4 horizontal bar size for each of the wall panel regions. So as it solves, it looks like it's solving now and it's just about to wrap up. I'm going to hit X in here. I'm going to go ahead and look for that wall panel. Again, I'm going to do a quick search, a quick find in there. And I'm going to type WP14A, which is the label of our wall panel. And I'm going to hit OK. So that will essentially select our wall panel in question, and I'm going to open the detail report again for this wall panel. Going to click the detail report button in there, and I'm going to go ahead and click on this specific wall panel. And the detail report will open up again. Now we see that the horizontal reinforcement in this case is actually a number 4 bar at 8 inches on center. And I'm going to scroll down to the seismic detailing check section, and it actually shows a pass now, which means that all of the seismic detailing checks uh, have passed. And I'm going to click in there to expand the seismic detailing checks for this wall panel region. And when you scroll down, you'll see that now we see a pass for the minimum horizontal bar size. That means that we have provided, we're in compliance with this specific requirement. And if you would like to see additional information about the seismic detailing checks and what the requirements are per TMS 42, you can actually see that the reference to the code is provided in the detail report as well. In this case will be section 7.3.2.3.1 for this particular requirement. And obviously the reference will change depending on which seismic detailing check we're looking at. Depending on which seismic design rule you have applied, some of the seismic detailing checks will differ. For instance, if you're choosing the route of special boundary elements, you may not see this maximum flexure road check, which is specific for the conventional reinforcement route to meet ductility requirements, and the seismic detailing checks provided will depending on each of the seismic design rules. So just keep that in mind as you look further into designing your masonry wall panels per the provisions of TMS 42-16. For more information of the seismic design of masonry wall panels, please visit RISA.com.